Hey, this is Presh Talwalkar. This puzzle was sent to me by email. Hi Presh, this problem is so up your alley and I am requesting a video on it. Take any equilateral triangle and pick a random point inside the triangle. Draw from each vertex a line to the random point. Two of the three angles at the random point are known. Let's say angles X and Y. If the three line segments from each vertex to the random point were removed out of the original triangle to form a new triangle, what would the new triangle's angles be? Try to figure it out. I was unable to do so, but I do have the unbelievable solution if you have any trouble. Regards, Daniel E. Now, I will say I did give this problem an honest effort, and I was stumped. Please help me solve this problem. Daniel then provided me with the solution. This problem also has an interesting background. There's a lot more about it in the video Simple Math Problems to Fool the Best on the YouTube channel Gold Plated Goof. The problem is also part of a collection of, quote, killer problems that were very easy to state and almost impossible to solve unless you knew a very specific trick. And as such, these problems could be used for discriminatory purposes at universities. So please check out these sources for more about the historical background about this problem and other problems. In this video, I'm just going to focus on the problem and show you the solution. So can you figure it out? Give this problem a try, and when you're ready, keep watching the video for the solution. So preliminary to get started is that the lengths of the three sides uniquely define a triangle by the side-side-side postulate. So we just need to find any triangle with the three sides blue, yellow, and purple, and then solve for its angles. So how do we do that? It seems pretty impossible. How can we get from this triangle's angles to the original angles? Well, let me present to you the ingenious trick. The problem becomes easy if you rotate the triangle 60 degrees from a vertex. So let's imagine rotating this triangle 60 degrees counterclockwise from the bottom left vertex. We now connect the random point on the rotated triangle to the original triangle. And we will show that we have now found a triangle with a blue, yellow, and purple side. So this will be the triangle, and we will be able to solve for its angles. So that's going to be the plan of the proof. Now, how do we know this is the particular triangle we're looking for? So let's work each step out. The first step is that the two blue lines form a 60-degree angle. This is because the triangle was rotated 60 degrees. But just to be sure we know this is a 60-degree angle, let's figure it out. Suppose the blue segment divided the equilateral triangle into angles A and 60 minus A. We'll mark the same angles in the triangle that was rotated. Now, the two blue lines make an angle of 60 minus A plus A, which is 60 degrees. So we've proved that this angle between the two blue lines is 60 degrees. Next, we'll show that the blue lines define an equilateral triangle. We'll form a triangle by connecting the endpoints of the two blue line segments. The two blue line segments have the same length. Therefore, we have an isosceles triangle with a vertex angle of 60 degrees. The remaining two angles will be equal to each other and the sum of the three angles in a triangle is 180 degrees. So each remaining angle will be 180 minus 60, and then we divide that by 2. So each remaining angle is 60 degrees. Therefore, all three angles of this triangle are 60 degrees, and so it's an equilateral triangle. So the very last side has the same length as the blue sides. So I'll color this last side in blue. Now what can we do from here? We now have the triangle that we're looking for with a blue, yellow, and purple side. So we'll solve for the angles of this triangle. The first thing we can do is we can solve that the angle between the purple and blue sides is x minus 60 degrees. Next, we'll solve for the angle between the yellow and the blue side. This can be done because in the original triangle, this angle is y. When we rotate the triangle, we know that the corresponding angle will be y, and the angle that we're looking for will be y minus 60. So we figured out two of the angles in this triangle, and we only have one more angle to figure out. So how can we figure out this final angle? Well, the sum of the angles in a triangle is 180 degrees. So the final angle will be 180 degrees minus each of the two angles we know, x minus 60 and y minus 60. So this will result in the angle of 300 minus x minus y. And that's the ingenious solution to this seemingly impossible problem. Did you figure it out? Thanks for watching this video. Please subscribe to my channel. I make videos on math. You can catch me on my blog, Mind Your Decisions. If you like this video, you can check out my books, which are listed in the video description. You can support me on Patreon, and you can also catch me on social media, either at Mind Your Decisions or at Presh Talwalkar.